Hello and welcome to this latest video in the OCR GCSE Computer Science series. This is another walking, talking mock, and we're going to be having a go at the first sample paper released for the J277 specification. So there haven't been any formal past papers for the new specification yet, so this sample paper is the only official paper for Unit 1. What we'll do is go through this one together. It'd be really useful if you had a printed copy of the paper. Attempt each question, and then I'll talk you through some model answers to get 100% marks on all of the questions, hopefully in the most efficient way possible. This is the content that might come up within any Unit 1 paper. So there are 6 key topics: systems architecture, memory and storage, computer networks, network security, system software, and the impact of technology. And within your Unit 1 exam in the summer, which counts for 50% of your computer science grade, any of these topics could be coming up, so very worth being aware of. Worth noting, if you're sitting your exam in the summer of 2022, there is a pre-release material that talks through topics that definitely will be included. That's available on the OCR website and is for 2022 only as a result of COVID-19 and the amount of time you had missed. So let's get cracking. Question 1 looks at character sets, letters, and some binary numbers. It tells you that the ASCII code for the character J is the denary number 74. It then asks what is meant by a character set. So a character set is a set of characters, funnily enough, that can be converted from a binary number into a letter. So it tells the computer what each binary character or binary set stands for. It is a table then to convert binary numbers to letters and or symbols. It defines all of the different letters that a particular computer can represent. ASCII has 8 bits per character, so the letter A, for example, would be 8 bits. Identify the maximum number of different characters that ASCII can represent. That is 256. The mistake would be to put 255. 255 is the maximum number we can create with 8 bits, but we've also got the number 0. So there are 256 different characters we can represent. Then a text file uses the ASCII character set. The text file has 2,000 characters in it. Calculate an estimate of the size of the file in kilobytes. Show your working. Really important here. We're only going to get 1 mark for the answer. The other mark is going to come for our work. So we've got 2,000 characters and each one is 8 bits. Times those together gives us 16,000. We know though there are 8 bits in a byte, and it's asking for our answer in kilobytes. So we can divide back by 8 to give 2,000 bytes. To then convert to kilobytes, we need to divide by 1,000. So we're going to divide 2,000 by 1,000 and get the answer of 2. You don't necessarily need the top bit because all we've done is times by 8, then divided by 8, but you certainly need the 2,000 divided by 1,000 as you're working. Identify one other character set. There's only one answer you can give here. There are only 2 character sets covered in the GCSE. It is ASCII Unicode. So the answer to that question is always going to be ASCII or Unicode, and they've obviously already told us ASCII. It then wants us to write the 8-bit binary number for J. Now we're told that J at the top is 74, so it's really important you've read the part at the top of the page. In effect, therefore, this question is asking what is 74 in binary? Now hopefully you've been taught how to convert from denary to binary. If not, there's a video on this channel talking through. The answer is 0100 1010. It then wants you to give the hexadecimal number for K, and it wants you to show your working. Now I know that J is 74. I should know that K is equal to 75. I'll need to convert K to binary, which is 0100 1011. When we convert hexadecimal, we then break those down into 4 nibbles. 0100 equals 4. 1011 equals 11, which you should know equals B. So the answer there is 4B. Again, that's a 2-mark question, and we need to show our working for full marks. Finally, on what is quite a lengthy first page of the exam, A binary shift can be performed on a binary integer, so a whole number. Identify which shift will multiply a number by 8. Now this is a 2-mark question. In 1 mark for saying it's a left shift, and to multiply by 8 we need to left shift 3 times. So each time we move to the left, we're timesing by 2, so it'd be 2, 4 and then 8 when we make our 3rd left shift. So a mark for left and a mark for by 3. Usually in Unit 1, the essay question comes towards the end of the paper. That allows you to use whatever time you've got left really to attempt the essay. In this paper, they've put it at question 2. Now you've got a couple of options. I would probably choose to skip over this, do every other question, and then come back to the 8-mark essay question. But we'll go through the order that it's in as we're doing this as a walking, talking mock. It asks you to discuss the impact of technology on medicine, including diagnosis, treatment, and storage of records. Now that's an 8-mark question. Whenever you get these essay questions, the bullet points will give you your paragraphs. So I want a paragraph about diagnosis, including some positives and some negatives. I want a paragraph about treatment, and I want a paragraph about storage of records. You don't need to write, okay, but what you shouldn't do is use massive handwriting and fill up the page and only really make 2 points. I've written 3 paragraphs, and in each paragraph I've made at least 2 points, sometimes 3 points. Now I won't read through that answer in full, but what I'd strongly suggest here is that you pause the video and think about the points that I've made under diagnosis, treatment, and then storage. We're then on to a question looking at the von Neumann architecture, the registers, and what each register is used for. A table has 5 components and 4 statements. Tick 1 or more boxes to identify which is true about each, which register relates to each statement. The answers are there. So the memory address register and the program counter both store single addresses. The cache stores frequently used instructions. The MAR, the MDR, and the program counter are all registers. And the RAM stores all of the currently running data and the instructions. It then asks for a register that's not in part 1. The obvious one is the accumulator. You should always remember the definition for an accumulator. To accumulate means to keep track over time, to keep taking things in and in and in. And that's what the accumulator does. It takes in the running total, the result of the calculations that have happened so far, the accumulative total of what's happened. So the register is the accumulator, and its purpose is to store the result or the running total of calculations. Next, we're asked about computers A and B, which have a single core processor and then different clock speeds. Explain why A will run faster than B. The danger here is people getting 1 out of 2, not 2 out of 2 marks. 2 different points. I've gone whole hog here and just bullet pointed 3 steps. Computer A has a higher clock speed. That means it can run more fetch, decode, and execute cycles each second, therefore processing instructions more quickly. Now on questions like this, bullet pointing your answers are absolutely fine, and actually bullet pointing quite often will signpost the examiner to the fact that you have made enough points. If you make sure each bullet point is a different point, you will absolutely guarantee that you're going to get those marks as long as all of your points are valid. You'll see later on in this paper, I use this bullet pointing method again. We then get a nice question where we're given a range of gaps and we just need to fill in the gaps. You should know in your GCSE, you've got 80 marks to find in 90 minutes. So you need to get 1 mark per minute. This is a nice question that isn't going to take you anywhere near 4 minutes to complete and should allow us to save back some time to complete that essay question at the end. It's all about embedded systems. Embedded systems have limited something. They're often built into a something machine, and then it asks for 2 examples. They have limited functions. They're built into larger machines. Examples are washing machines and automated lights in a car. We then move on to question 5, where we've got Layla, who's an artist, and she draws images by hand. The images are then scanned into her computer. We've got a tick box, and this tick box quite clearly says tick one box in each row to identify whether it's true or false. You will screw yourself over if you put two ticks in the same row, because you're definitely going to get no marks. So each colour has a unique binary code, true. Metadata stores the colour, well, no, it doesn't. A bitmap is made up of pixels, yeah, it is. And the higher the colour depth, the smaller the number of colours is definitely false. Each image then has a fixed size of 1 megabyte. The storage device has a capacity of 3 gigabytes. How many images can be saved? Well, I'm going to take my one image, I'm going to times it by 1,000, and I'm going to times by 3. So I'm converting to gigabytes by timesing by 1,000, and then I've got 3 gigabytes of storage, so I times by 3. The answer there is 3,000 images. There are 3,000 megabytes in a gigabyte. Again, on this question, they're asking us to show our working. Really important that you do that whenever you're asked. Layla uses the images to make videos. The videos are stored on her computer on the internal storage device. Identify the most appropriate type of storage for Layla. Now, you can pretty much justify any point. I'm going to go with solid state storage, and my reason is going to be that it's very fast, it's robust, and it's got a large capacity. So 3-mark questions. So we want to make sure we're giving a suitable storage device, a type, e.g. you can't say hard drive because the type is magnetic drive, and then a couple of reasons why. And again, it's absolutely acceptable to bullet point those when you get those sorts of questions. The videos will include sounds. The table has 4 statements about the storage of sound in a computer. The person writing this paper obviously wasn't feeling particularly creative this day, so we've got another tick box section, another time where we've got to tick just one of the possible answers. So sample rate is the number of times the amplitude is recorded per second. The smaller the bit depth, the smaller the range of sounds recorded. The larger the sample rate, the larger the bit depth. The frequency and pitch of the sound wave are measured, and that sound is stored using. Those are the answers there. The second bottom one is slightly controversial. The frequency and pitch of the sound wave are measured. Well, it's only the height of the wave that's measured. It's the amplitude of the wave that is measured. That's all we measure each time. So we would get the frequency by taking lots of samples, but the frequency isn't directly measured. Layla uploads those videos onto a website, and she's going to compress them. Explain why Layla might compress the images and videos before uploading them. And again, we need to get 2 marks here. So I need to give 2 reasons why she'd want to compress these videos. This is another example of a question that I would definitely bullet point. Show the examiner that you are making 2 points to this question. Well, we want to reduce the file size, and that means we reduce the upload time. If we're uploading a mammoth file onto OneDrive or something like that, it's going to take ages and ages to upload. Layla wants to reduce the file size of the videos and images by the largest amount possible. Now that's the big hint in this question. Identify the method of compression that would be most appropriate, justifying your choice. The only answer you can give there is lossy, because it says she wants to reduce the file size by the largest amount. Lossy compression will reduce the file size by the largest amount. It will remove some data, but should not be too noticeable. Now again, if you've put lossless, you're not going to get your marks there for that question. Lossy is the only answer. Layla wants to protect her images so they can't be copied by other people. Identify the legislation. Well, the legislation is the Copyright Designs and Patents Act, but you're probably going to get the benefit of the doubt if you just put copyright. But that's the formal name of that legislation, and that's one of very, very few that you need to remember as part of your GCSE. AMI has a home network that includes 2 laptops, 4 mobile phones and 2 televisions. Identify the type of network. Pretty much whenever they ask that, they're asking, is it a LAN or a WAN? A local area or a wide area network? The answer there is it's a local area network. It's just one home network over a small geographical location. We've then got quite a tough 6-mark question. It's asking us to describe the similarities and differences between a switch and a router. When my class did this for the first time, this was a question they really struggled with. And like I say, making 6 points here is quite difficult. We need 3 similarities and 3 differences. So, they both connect devices. That's easy enough. They both receive data packets, and they both transmit data packets to its location. They send those data packets on the correct path towards their location. The differences are then pretty tough. A router uses IP addresses, Internet Protocol addresses. A switch, though, uses MAC addresses. A router connects to the Internet, hence it uses the IP addresses. So you can't connect to the Internet with a switch, but you can connect to the Internet with a router. You could also say that a local area network would only have one router, whereas it might have multiple switches. We've then got a nice final question on this page, which is asking us to draw this network in a star to. The important bit here is that you've got the switch and the wireless access point in the middle, and everything else branches off from that switch. That's the definition of a star network. Everything branches from that central node. Ame wants to protect the computers on his network from threats such as unauthorized access. Complete the table. So this again is quite a big question. 6 marks available. We've got to name 2 forms of attack, 2 descriptions, and 2 methods of prevention. A brute force attack is a program attempting all possible password combinations. The method of prevention there is strong passwords. I don't think you're going to get anything there for saying change your password regularly, because while changing your password might stop repeated attacks if someone's already guessed your password, it's not going to stop them from trying to brute force your password, but a strong password will. Data interception is all about data packets being read during transmission. That during transmission part is important, and the way to stop that is by encrypting those data packets. Finally, malware or viruses, software that damage data, and the prevention is given to us, and that's the antivirus. Another fairly lengthy question here. Evie's computer has system software, including the operating system and utility software. She runs disk defragmentation. Explain why Evie's computer is more efficient afterwards. The tough bit here is we've got to get 3 marks. We've got to make 3 very separate points about how disk defragmentation will help make her computer more efficient. Well, defragmentation is when we put all of the files that are related into one part of the disk. So files from the same program are moved so that they're next to each other. The disk has therefore to move less far, if we're thinking about a magnetic disk with a moving arm, therefore data loads faster. Free space is also kept together so that future files don't have to be split up. It's all about that idea of on an old-fashioned magnetic hard drive, the moving arm has to move less far and less times, and that makes the computer much more efficient and therefore much faster. Another tick box question. I've never seen this many tick box questions in a real exam, but tick 1 box in each row to identify which function of the operating system deals with each action. So we're given a number of different actions and then some features: memory management, peripheral management, file management, and user management. There are the answers for that one. It does say just 1 per box, so those are going to be the only correct answers that you'll have accepted as part of this one. Evie then wants to write a computer game, and she wants people to be able to download her program. Give 2 benefits of choosing an open source license. So an open license allows Evie to distribute it free of charge, so that's good for everyone getting the game. And others can add features to it, and that's good for everyone. So open source allows other people to see the source code, make changes and make improvements to it, which can mean that we can get lots of features added very, very quickly. Obviously, we don't know the quality of those new features. Anyone being able to edit the game does mean that anyone can make mistakes, but there are also times where that is a good thing. Getting towards the end of the paper now, we've got to give 2 benefits to Evie of choosing a proprietary license. So what this is really asking is, do you know what a proprietary license is? Well, that's the one where she can charge money for it. She's not going to give it away for free, so she's going to make money. It can also restrict what others can do to the software, potentially keeping the quality of the software higher. So by allowing anyone to edit it, we might be getting bugs included from some people who aren't particularly good at programming. Proprietary license leaves Eve in total control, of who can edit her code. We're then asked, in short, to describe the benefits and the drawbacks of the cloud. So we're thinking Google Drive, OneDrive, something like that, some cloud-based storage, and we're asked for 3 marks for each one. So really this is a 6-mark question about the positives and the negatives. Again, you'll see that I'm bullet pointing my answers. I'm really directing the examiner towards the fact I have made 3 very different points. She can access her data from anywhere. She won't need to carry external devices such as pen drives around with her. And the backup is likely to be managed for her. So Microsoft deal with backing up OneDrive automatically, and Eve won't need to. There are some drawbacks. It requires internet access. Data could be intercepted while she's downloading it from the cloud, and the security is out of her control. So if Microsoft were to get hacked, her code would then be lost. Now that marks the last question in this sample paper. As I say, it's a sample, but it is a sample from OCR, so it's a formal sample paper. And it is as close as we're going to get to past papers for J277 until the summer of 2022, when the first cohort undertake the new version of the qualification. There are, though, lots of past papers for the previous specification and lots of walking, talking mock run-throughs of those available on this channel. As always, thank you for watching. If you do have any questions, please post those either onto Google Classroom or into the comments section below. Thank you for watching.